It's a way to show a molecule, to how it's structured, a molecule structure. So this guy, Lewis, I don't know his first name, Lewis came up with a method to write Lewis structures. Okay? So what we're going to do is we're going to give you the steps. It's called Lewis dot structures. So they're all going to have these dots in them that you guys went through. Before we do this, before we do this, you had an assignment, and you had to, because I'm going to run out of time, I'll just do them real quick. You guys have questions, you can ask. How did you come up with that? Why is that the number of dots you used in doing this? Phosphorus is the first one, and phosphorus looks like this. I have to really make my dots big. So. That might be too big. Okay, so phosphorus will look like this. Oh yeah, good. That's not right. I got carried away looking how good my dots were. Man, that's easy. I don't have to do any circle. I just have to, boom, there. Okay, questions on that? It's an S2P3. Okay, S2P3. Okay? Chlorine looks like this. Questions? Okay? Carbon. Yes?
Okay, does it matter like what side the double dots like
No,
on?
it doesn't. And even in the book, carbon is written like this, and it would be fine to write it like this. And there's a reason why they chose to write carbon like this. And we'll bring it up, not right now, but we'll talk about it in the future. Okay? For right now, we'll just leave it either one of those two ways is fine to do it that way. Okay? And then selenium. And then argon is that one that's not going to be shown in any compounds because it has an octet of electrons. So an octet of electrons means when you count around it, that there's going to be 8. So you guys are just going to have to not worry about that down there. It keeps coming up. We'll just do it without worrying about it. Any questions on those? Jeff. Okay. All right. So we move on to the writing of Lewis structures. So you already have that written down. These are the steps that we're going to use. I need to make my icon a little bit smaller. Okay. So this is the first step. It's funny how some people have certain sneezes, you know. Some are just loud and boom out there, and other ones they try to hold back, and it's hard to do. It hurts to hold it back. Some of you have a little high pitched. Everybody's unique on that. Write out each dot notation for each atom in the molecular formula. And I haven't given you one yet, but I will. Okay? So write out each dot notation for each atom in the molecular formula. So here's your molecular formula. we're going to give you a molecular formula that's PHCl2. Now we know that's a molecular formula because they're all nonmetals. We know it's a chemical formula because we're given symbols and numbers of every atom and how many we have within the actual molecule. So this would be an actual molecule. It's made up of 1 phosphorus, 1 hydrogen, and 2 chlorine. Okay? That's what it's made up of. So that's what I'd like you to do. The first step, I'd like you to write out 4 dot notations, 1 for phosphorus, 1 for hydrogen, and 2 for chlorine, like we did for today. Okay? So write out the dot notation, the ones we just went through. In fact, you already have phosphorus and chlorine written out. So you know what those are, but you still have to write them out here. Right? If you would do that, that would be great. Now we haven't written a structure yet, or we haven't shown you a structure, but if we had a structure and we start forming it, the symbol of the element that needs the most electrons to get 8 is going to be our central atom. Okay? So if we go back to your notes in front of you, which one of these 4 need the most electrons so that it can have 8 or an octet? Now, the thought would be hydrogen. And let me tell you a little bit about hydrogen. Hydrogen is not like the other nonmetals because in its shell, to get a full outer shell, it only needs 2, right? It can never have 8. So hydrogen is kind of this one element of these nonmetals that only need 2 electrons, and then they have a full shell because the first shell only has 2 electrons in it. If you look at any other nonmetal, carbon, nitrogen, oxygen, fluorine, chlorine, phosphorus, they're all going to have 8. But hydrogen doesn't. So hydrogen will never be in the center. Never in the center. Yep.
So it'll be phosphorus?
So phosphorus has to go in the middle because it needs 1, 2, 3 electrons to get 8. Chlorine needs 1 each. So you'll find out the chlorine and fluorine and that halogen group that needs 1, they'll never be in the middle. Okay? Only phosphorus in this example will be in the middle because it needs 3 electrons to get a total of 8. So what we'll do is we'll put phosphorus in the middle and then we'll surround it with the other symbols. Does it matter which symbol goes where? No, as long as they're kind of like it. 90-degree angles, 6 o'clock, 9 o'clock, 12 o'clock, 3 o'clock, kind of that. Kind of always that, 90-degree angles. So phosphorus is in the middle. Any questions with that? Yes?
Does it matter where you put the other ones?
Nope. Nope, it doesn't. I could have chlorine, 2 chlorines away from each other, hydrogen on top. I could have chlorine up here, nothing down below. Doesn't matter. Okay, because this is going to rotate, right? So we're looking 2-dimensional. If we came out, blew that up, 3-dimensional, rotate it, doesn't really matter. Because it's going to rotate and move, and it can be any way you want it to be. Okay, when you move it around. Okay, so the next thing we're going to do, number 4, we're going to do place a pair of electrons in between the central atom and the branched atom. At least one pair. Okay? So place a pair of electrons between the central atom and all the branched atoms. So originally we had 20 electrons we're doing. We're kind of going, we got 20 electrons. So then we're going to go ahead and place shared electrons. That's what they're called, shared. You're going to hear me throughout this chapter talk about shared electrons, or shared pair of electrons, and unshared pair of electrons. These are shared because what does that pair go with? Does it go with phosphorus? Yeah. Does it go with chlorine? Yeah. So they're sharing. So if you place them in between, that represents a sharing. They both share those electrons. Okay? So that takes away 6 total electrons. We've got to keep track of our electrons. We have what's called conservation of electrons. We've got to use them all up. And we can't have extra. We can't bring in extra. They're not going to allow us to do that. Okay? Number 5. We only got 2 more. Yes?
With the dots in the middle, where do you get those from? Like, does it matter? Do you just always have those 6 dots in between? Or?
Nope. I could have, like if I had a symbol up here, Christina, then I'd have to put another pair in between that and that top symbol.
Okay, but it's always going to be like between the 2 elements, there's always going to be 2 dots?
Always going to be a pair between each one.
Okay.
Yeah, on this step. You just like now. There's several ways in which you can show Lewis structures and how they're put together, and I've done it some different ways. But I find that these steps really help students that like it step by step to see the process of how this fills in. This seems to work really well. Okay? Really well. So that's why I'm sticking with it. Okay? Number 5, we've got we got 14 dots or 14 pairs of 14 electrons left over. So we're going to have to use some of those more up, and this is how we're going to do that. Okay? We're going to place an unshared I'm just going to say place unshared pairs of electrons around each branched atom and I'm going to put in parentheses exclude which element? Yeah, exclude H. Okay? To get an octet of electrons. Okay? So we're going to go ahead and start using up the rest of that 14 electrons. So we go back and we have 6 used up. Now we're going to have to start putting some of these electrons around the branched atoms. Not going to do hydrogen. So 2, 4, 6, 8, 10, 12.
You put some in the B, cup B.
Not yet. Okay, we're going to keep it simple. And you probably know where that extra pair goes, right? It'll go off the top. But we're going to keep it simple for now because then we're going to have some double bonds and triple bonds tomorrow that we want to follow these steps. Okay, last one. So we've got everything but 2 electrons. Octet rule, it's got 8. 8 only needs 2. The center one only has 6. It will have to have 8. So what we'll do on our last one, number 6, says any electrons left over you'll place off the central atom. So any remaining electrons will be placed off the center atom. And then when we do that, you're going to get 8 around it. So then everything will have 8 around it when you're done. So those are 6 steps. Tomorrow, we're going to go through what happens when we run out of electrons and not everything has 8. Everything has to have 8. Okay? You can use the electronic one. I got that one. That one's good shape. Okay? So here it goes, right in here. Okay? So, 8, 8, 8. Used them all up. Got them all taken care of. Count them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 20. Okay, so up on the board here, you have 3 to do for tomorrow. I will check these. If you don't have them done, then you may have possibility for a makeup assignment that you didn't get done. You might have 5 of these to do to get credit for it. So do these 3. They shouldn't take you that long to do. Follow the steps, and we'll see how well you did. I'm not grading for right and wrong answers. You do the best you can. Follow the steps for those 3.